In this video, I'll try to find the kth largest number in an array using Python. Bottom statement, I'll find the kth largest number in the array. The input is an array, the output in k, and the output is the kth largest element. For example, two examples are when a is this, a is the array. When k is 2, the third array is this, and the second largest number is 6. The reason why it's finding the second largest number is because k is 2. When k is 3, I'll find the third largest number because k is 3. So the third largest number is 5, and the second largest number for example 1 is 6. Observation 1. If the array is sorted, kth largest element index is, which I'll be calling k index from now on, is array length minus k. So when k is 2, the array is this, and the array length is 5, and the k index is 5 minus 2, which is 3. And then, so 0, 1, 2, 3, so it'll get the answer 6. So that's how you could find the answer for this problem. So the k index would be 5 minus 2, which is 3. When k is 3, the k index is 2 because 5 minus 3 is 2, and the length of the array is 5. That's why I'm using 5. And so 0, 1, 2 is 5. So the answer would be 5. So this would work on a certain array. Quicksort partition algorithm will return the sorted position for any pivot value without sorting the entire array. So you just need to find the k index and only sorting the k index's place. If the pivot position equals to k index, we know that pivot is kth largest value. For example, in example 1, when k is 2, k index is 3 because 5 minus 2 is 3, and we're using an array that has a length of 5. And if pivot is 6, and which is at index 3, through quicksort partition, when 6 is the second, it'll make it so 6 is the second largest number in the array. I'll figure that out. So in this example, when pivot is on index 3, it'll partition this to make 6 be at the right place, and then it'll return 6 because that means it's at the right, that means this number is sorted, the k index number is sorted. So that's the answer. When k is 3, k index is 2, since k index, which is 2, is smaller than pivot index, which is 3, it'll search the kth largest element on the left side of pivot, which is 2 for here. For the quicksort partition, before partition it'll be this, and after partition it'll be this. I'll pick a pivot. You can use any element as pivot. In this example, it'll use the last element. The law of the partition will be elements smaller than the pivot will be on the left side of the pivot, and elements bigger will be than pivot will be on the right side of pivot. So as you can see here, after partitioning 6, pivot will always be in the right place. So if you partition one number, that means it'll sort that one number, and everything to the left will be smaller. Then partition everything to the right will be bigger. So as you can see, 6 will become here. Everything smaller than it will be on the left. Everything bigger than it will be on the right. And as you can see, if you look at a sorted array, 6 is still on the same spot because 6 has been sorted by partitioning. Function partition takes the input of a, low, and high. Low and high are both 2 pointers. Low points at the beginning of the array, and high points at the end of the array. I, j both get low's value, which is the start of the array, and pivot gets high's value, which is the end of the array. And then it'll go into the while loop because j is smaller than pivot, and then because j will go through every element in the array and compare it with 6, which is pivot. And since 7 is bigger than 6, it'll increment j. When 5 is smaller than 6, it'll swap 7 and 5. So you can move the smaller values to the front. And then you increment I because I always points the first number bigger than pivot. Increment j to check the next element in the array. Since 4 is smaller than 6, swap 4 and 7 and increment I and j. Since 2 is smaller than 6, swap 7 and 2 and increment I and j. It's swapping 7 and 2 because I is at 7 and j is at 2. Since this is equal to 6, it'll swap 6 and 7 and increment I and j. And after incrementing j, that means j is not smaller or equal to pivot, so it'll go all the while loop, and then we'll print pivot's new value, which is new index value, which is 3. And then pivot is now sitting at the right sorted position. Function k largest takes the input of a, low, high, and k. A is the array, k is 3 in this case, and low starts at the beginning of the array and high starts at the end of the array. Now I'll partition, and pivot becomes the shaded value, which when pivot is over here, it'll be over here. In k index, now is linked a minus k to find k indexes, and then since pivot is bigger than k index, it will call itself to go to the left of pivot to look at the left side. Then I'll partition again, and then because pivot is smaller than k index, because pivot is over here, k index is over here, it'll go to the right of pivot and to the left of the old pivot value. When pivot is equal because pivot is equal to k index, after partitioning, pivot will be here, and since it's equal to k index, it'll return the kth largest value, which is 5, so the output is 5. To swap, for the partition, it'll swap. So to swap, it'll store the first value, AI, in temp. That's, temp is a variable, and AI gets AJ's value, AJ gets temp's value, and now AI and AJ are swapped. For example, when A is equal to this, I is equal to 1, and J equals to 2, so I is over here, because AI is this, and AJ is over here, because AJ is here, and after swap, it'll swap -3 and 2, because I was 2, and J was -3. The end.